All right, I think it's 8:30. Shall we start? Xin, you ready?
Oh, yeah.
Okay, I guess let's start the session.
All right. It's good to see all you, and I'm saying hi from Australia, Sydney. I realize that this session is mostly about kids, language acquisition. So my talk is really about adults. I'm the first author, Xin Wang, from the Linguistics Department, Macquarie University, Australia. My title is Cross-Modal Perceptual Learning in Learning a Tonal Language. Let's see what I can just see from here. All right, let me introduce you to lexical tones first. In a tonal language, for instance, in Mandarin Chinese, there are 4 different tonal categories. I can show you an example here. A symbol like ma can be associated with 4 different tones, which gives you different lexical meanings.
Ma, 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 ma.
So these are the 4 different words, only contrasted by the pitch contours. Pitch contours can be acoustically measured in F0 height and F0 contour. I want to show you another demo where the meaning of the discourse is primarily driven by lexical tones. I'll just very briefly show you how the tone in one syllable works, which actually demonstrate a particular discourse.
实事事事事事事实事实实施事实是实实事事事事实实事实是事事事实事实是事事
Okay, so you get the idea. So I'm not going to play the whole thing.
实事是
So if you look at the literature of learning L2 tones, there are primarily 2 theoretical approaches. The first one is multisensory learning theory, which means that the sound to meaning mappings benefit from information from different modalities, which leads to a more distributed and robust representation. Evidence for this is primarily coming from visual cues like facial expressions or the movement of articulators, which can support learning auditory tones. The second theory is embodied cognition, which means that using hand gestures to illustrate auditory tones contributes to improved or better representation. And there's more consistent evidence supporting this kind of idea. There are studies investigating using multimodal inputs to facilitate learning auditory tones. So I look at the literature. There's in the visual domain, relatively speaking, the results are quite mixed. Some results show the benefit of using visual pitches, and some studies fail to show that. And these visual pitches are primarily represented by numbers or some kind of signs to referring to represent different tonal categories in a particular language. The second line of evidence is demonstrated in the visual modal domain. Actually, the evidence is much more consistent, showing the benefit of using gestures to enhance learning tones. I want to introduce you to one particular study which was recently published. What this study shows is that hand gestures that visually illustrate pitch changes can facilitate perceptual learning. What they tried to hypothesize in the study is that cross-modal learning is best when it is based on a common representational format of features across modal, visual, and auditory domains. So in the study, they present participants with 3 types of input in addition to auditory tones. So the first type of input is congruent pitch to gesture pairing. So in this kind of pairing, participants were demonstrated with the videos which show the visual alignment across gesture and auditory tones. So for instance, tone 1, which you can see from the video, that the hand movement is from left to right, and for the flat tone, so that's tone 1. For tone 2, the visual cues show the gesture moving from left to right and upward. And tone 3 is downward and upward and also from left to right. So two-dimensional, right? And the fourth tone would be the downward hand gesture and left to right. So this is a pitch to gesture pairing, congruent condition. The second condition, they demonstrated participants with a rotated pitch to gesture pairing, where the visual alignment between the gestures and tones were removed, but participants were able to see the menu movement. So the rotation is roughly like a 90 degrees. So the participants were able to see the hand gesture is inward and outward, right? So there's only one dimension from this perspective. So the third type of pairing is the incongruent pitch to gesture pairing, so which is more like a baseline condition. In this between subject design, they ask participants to perform or watch congruent or rotated trials in addition to listening to tones, or perform incongruent trials while listening to auditory tones. And there's another condition where participants simply just listen to the tones. So across the board, there are 6 conditions. So either perform or watch, or simply just listen to auditory tones. The task that they ask participants to do is the tone identification task. And this is a very typical task in speech perception, where participants were presented the auditory tones and then they indicate by pressing one of the 4 buttons, which tone the auditory corresponds to. In the pre-test, you can see that across the 6 different conditions, there was no significant difference. In the post-test, I believe that they give each participant 2 exposures of each token. The conditions that show significant advantage is the performing congruent trials, watching congruent trials, and performing rotated trials relative to auditory only condition. And the watching rotated trials did not show significant differences relative to auditory only condition. And the performing incongruent trials actually show a little bit of inhibition, which was not significant. They also run the same kind of task with different tokens as the generalization test and the follow-up tests, and they show the similar pattern. So they conclude that cross-modal learning is mediated by common properties shared by visual modal and auditory modalities. So in our study, we want to understand whether this compatibility factor across modal and auditory modality would be observed across visual and auditory modalities. So we ask questions, does the visual input, which provide spatial and temporal cues, facilitate tone learning? We ran this study online using Gorilla as a data collection platform. This is a training condition we designed in our study. So we had an auditory only condition where participants simply were exposed to the auditory tones. So I'll give you an example here as a token.
Oh.
In the static contour condition, in addition to the auditory tokens, participants were also presented with a static contour where they were given a line which indicates corresponding to the auditory tone. In the animated contour condition, we present participants with the animated contour, which give them some kind of temporal cues, something like this, in addition to the auditory tones. In the animated incongruent condition, in addition to the auditory tones, we present participants with mismatched visual pitches. So this is basically the training conditions we designed in this study.
Oh.
The structure of the study is across the 4 different training conditions. Prior to training, obviously, we need to do a pre-tests. And for across the board, all the tests were done in the tone identification task, which is consistent with the study I introduced you just now. During the training block, we gave them feedback. So across the 4 different conditions, they all listen to the auditory tokens. In the visual conditions, we gave them either static contour, or animated contour, or incongruent animated contour. Each token, we gave them 6 exposure across 3 training blocks. And after a short break, they were tested with the same token, obviously without feedback. So that's the post-test. And then we gave them a generalization test, which they were tested with new tokens, different tokens in the same task. After 24 hours, they were given a link, then they went into the study, and then they performed the same task with half of the tokens were the same tokens they heard before. And we also gave them new items to see that they were able to generalize the the tonal knowledge they've learned before. So this is a general structure of the study. With regard to the tokens, the stimuli, we had 6 simple Mandarin vowels. For each can be associated with 4 different tones to generate 24 targets. And each participant was trained on 3 different vowels. So across the board, during each test, they were only tested with 12 trials on the 3 different vowels. And we had 2 counterbalanced lists for them. For the generalization test, 24 targets were generated from 6 diphthongs, which were associated with 4 different tones. Again, half of the items were used to test immediately after the post-test, and the other half were used in the delayed generalization test. And the participants we had in the study are native speakers of English. So here we plotted the accuracy results for the tone identification task. In total, we had 233 participants across the 4 different conditions. Analysis, we used LME, GMER simple models because the complex models failed to converge. And we also used the admin package for pairwise contrasts across between conditions. In the pre-test, we didn't observe any significance across the participants. In the post-test, the incongruent condition differs from all the other conditions. And the visual condition, where they either were given a static contour or animated contour, they show advantage. However, only animated contour condition had a significant difference. For the delay tests, where they were given the same item they were trained before, the significant differences between the auditory only and the static contour condition emerged. And the animated contour condition also differ from the auditory only condition. The same pattern for the incongruent condition, which differed from all the other conditions. For the generalization tests, which they were given new items, this is very similar to the pattern, very similar to the results of the post-test. The statistically only animated conditions show differences. Even both visual conditions show some advantage. And again, the incongruent condition differ from all the other conditions. This is the results from the delayed generalization tests. Same pattern as the generalization test, where for the new items, both visual conditions differ from the auditory only condition. And incongruent conditions differ from these 2 visual conditions, but these 2 conditions was not significantly different. We also did analysis on the tones to see that whether they perform differently across 4 different tones. What they found is that there was no effect of the tone at the pre-tests. However, there was a main effect of the tone at the post-tests. And we found that actually tone 1, tone 3 were learned much better than tone 2 and tone 4. So obviously in English, tone 1, tone 3 are quite novel, right? They never exposed to this type of pitch patterns. but tone 2 and tone 4 actually exist in English, so they might get confused. So we reason that that might be the novelty effect, where they actually show significant better learning results in tone 1 and tone 3 relative to tone 2 and tone 4. So these results show that the incongruent condition appears to destroy learning compared to the other conditions, which is actually consistent to the 2019 Gen study. And both visual conditions show advantage in the immediate tests for both old and new items. However, statistically, only animated conditions show advantage relative to auditory only condition. And both animated and static control conditions show advantage in the delay tests for both old and new items. However, the differences between these two visual conditions is not significant. What we can conclude from here is that arbitrary associations between novel visual stimuli and linguistic auditory stimuli do not benefit learning. And visual pitches, which can be mapped to auditory tones in the spatial and temporal dimensions, facilitate learning. And this supports the hypothesis that cross-modal learning is best when it is based on a common representational format of features across modal, visual, and auditory domains. And our results also show that learners benefit from meaningful cues when learning novel speech sound. All right, that's the end of my talk. Questions?